Hi everyone, so welcome to the second video tutorial at Learn Math with Rosie. So today we're going to talk about something very important, that's mastering the unit circle. So you cannot believe how many students have come up to me in the past, even at the university level, and saying that I have no idea how to work with the sine, cos, tan, cotan, stuff like that, and they're very abstract ideas for me, and I have no idea what they mean, etc., and they just, at some point they just give up working with them. So today we're gonna learn how to master this circle and understand whatever the fuck this means, and it's gonna be very useful for us in the future, trust me. So you guys would want to tune in and listen very carefully to this video, because you're gonna be stuck with sine, cos, and things of that sort for the rest of your life. So let's get started, shall we? All right, so I'm gonna go ahead and share my screen with you guys here. So let's get started. The first thing that I want to talk about is how the unit circle even looks like, right? So the unit circle, basically we've got something like this, right? Obviously, because it's a circle. Genius. But what happens is that we have something different on the x and the y axis, right? So the x-axis is not x, it's actually the cosine axis, so cosine of x, and the y-axis is not the y either, so it's the sine of x, right? So, and what happens here is that the unit circle, the reason we call it the unit circle is that the radius is equal to 1. Okay, so the radius of this unit circle is equal to 1. So now, right off the bat, let's jump into getting a, taking just an angle, right? So I want to take an angle, we always start with 0, so that's the 0, this blue, right? 0. And we always go anti-clockwise in the unit circle, right? We always go anti-clockwise, and that's the positive direction. If you go clockwise, it's the negative direction. Okay, so to the left is your positive. But right now we're just going to focus on the positive direction. So let's go ahead and take, 30 degrees. Why not? Okay, let's take 30 degrees, something like this. This is much more than 30 degrees, but you guys can just pretend like it's 30 for the sake of this, this illustration. Okay, so this is 30 degrees. And now we want to see, okay, what the hell cosine and sine of 30 are, and what it means to have sine and cosine of 30 on this unit circle, right? So look at this point right here. I'm gonna just take it out, okay, and I'm gonna connect it straight connected to the cosine sine line and the sine line, right? So I'm gonna go ahead straight down right here. You see where it hits? This is this value, the length of this value is the value of cosine of 30. Okay, and I'm going to go straight connected to the sine line. Okay, and do you see where it hits right here? This is the value for the sine of 30. So you can even take a ruler, right, and just find the value of sine of 30, right? And obviously the value of sine of 30 and cos of 30 are less than 1. Apologies for the lovely handwriting. Less than 1, all right? So why are they obviously less than 1? Because you cannot go out of the circle, right? The circle, the radius, this blue line is 1, so it always has to be less than 1, which does comply with the mathematical rules that we have, right? So let's take our calculator right here. So we're going to punch into the calculator what the value of sine of 30 is. Okay, so it's half. Does it make sense that this meets our line halfway through? So this guy is half of this. It looks like it for sure. And if you guys actually tried it in the real world, it would work as well. So this is how you would basically draw the sine or cos. So now my question is for you guys. Let's say I give you a true or false question, right? So we have something like cosine of x, and we have something like sine of x here. Okay, so if I say I'm going to start with an angle, and I'm going to start increasing the angle, what happens to the value of sine and this value of cos? So this is my second angle, for example. This is the increased version, right? And this is the small version. So small and then big. Okay, so let's compare the values of sine and cos, right? So initially, I'm going to take this, as we did before. We're just going to go ahead and connect it to the cosine line, right? Straight to the cosine line. So this is a value of cosine. So now let's compare that with the value of cosine when the angle gets big. So let's go ahead, take this. It's going to go down. Okay, we're going to go down. And do you see that the value of cosine has decreased? Okay, so the value of cosine is smaller. This value, this line, the length of this pink line is smaller than the length of the orange line, right? It's smaller. So let's take another color and see what happens to sine. So here we said that value of cos decreased. Okay, so sine at the beginning, I'm gonna go ahead and write a straight line, straight to sine. This was the value of sine. Let's take another color. We're gonna go ahead and connect this straight to the sine line. Look at that. The value of sine has increased. Okay, the value of sine has become larger. So, does that make sense? Hell yeah, it does. And I'm gonna show you guys a formula here that you can use to find the sine of your angle, or cosine of your angle if you're given the other variable, right? So if you're given sine, you can find the cosine. If you're given cosine, you can find the sine. Okay, and that's pretty useful, right? Because sometimes they just give you, I don't know, sine of an angle or whatever in a question. You can just calculate the cosine very easily. So let's draw that again one more time. I want to make it a little more clear and a little more obvious that we're going to be wink wink talking about the Pythagorean theorem here. Okay, so you guys probably know the Pythagorean theorem. We learned it in high school. We have a right angle triangle here, right? And here, for example, is the length is A, the length here of this side is B, and this is the right angle, and the length of this side is C. The Pythagorean theorem says that A squared plus B squared gives us C squared. Right? So let's take a look at that here. So I have it, whatever angle I have, right? I choose, I don't know, 42, right? Something like this. I'm going to choose a random angle. And I'm going to go ahead and connect. Okay, write this here. So here is a right angle triangle, right? I don't think there's anyone who disagrees with that. This is a right angle triangle because I decided to go straight down and create a right angle triangle. So this is cosine of x, okay? And as I mentioned before, here, this is sine of x, right? Now, let's take a look at it here. So this blue line here is exactly the same as this guy, right? So to make it a little more obvious, do we see a right angle triangle here? Good. We see a right angle triangle here with the angle of 90 degrees right here. So we can say the green side to the power of 2 plus the blue side to the power of 2 is equal to radius to the power of 2, right? So the green side, what is it? Is cosine of x. So we say cosine of x to the power of 2 plus blue side, right? Is the blue is the sine of x to the power of 2, okay? And what is the value of my radius? We mentioned that this is a unit circle, so the radius is always equal to 1. And don't ask me what the units of 1 is. Is it meters, centimeters, whatever, because obviously it depends on what kind of questions you're doing. In essence, it does not have a unit. It's always equal to 1, right? But if you applied this to like a physical question, right, you could quote unquote put a unit on it. But in essence, in definition, it has no units, okay? So the value of that is equal to 1 to the 2, which is just equal to 1. So this is, we basically created one of the very, 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 very important formulas in trigonometry. So that's cosine to the 2 plus sine to the 2 is equal to 1. Okay, so if I give you that the sine of x is equal to 1/2, plug it into formula, find the cosine. Easy, right? We're going to do an example of that right here, but this is actually, you know, like I cannot like explain how important this formula is, right? So just put it down. It's important. It's going to come up 1,000 other times in the future, okay? Whether you guys are doing math, trigonometry, or whatever you're doing, this formula is going to come up even in physics, right? So trust me with that, write it down. Now let's do an example of that. Okay, so we have an example of a you know, whatever scenario we have. I tell you the sine x is equal to 1/2, right? We did before, we did that, we mentioned that for sine of 30, the value of sine is equal to 1/2, right? So now what's the value of the cosine of 30? Let's say you forgot your calculator, right? You don't want to put in cosine of 30 inside your calculator. So what are we going to do? We say we know that cosine of x to the power of 2 plus sine of x to the power of 2 is equal to 1. Now what's the value of sine of x? 1/2. So I'm going to plug it in with 1/2 to the power of 2. Good. So cosine of x to the 2 plus 1 over 2 to the power of 2 is 1 over 4. Okay, gives us 1. Nice. So we have one equation, one unknown. Put the 1 over 4 on the other side. Gives us what? 4 over 4, which is wink wink 1, minus 1 over 4 gives us 3 over 4. Is cosine of x to the 2. Okay, so what's the value of cosine of x? It's square root of 3 over 4, which is square root of 3 over 2. Cosine of 30 is square root of 3 over 2. You found it, okay? You didn't even need to memorize that. You just needed to know that sine of 30 is equal to 1/2. So I'm going to keep today's video at this length, and hope you guys enjoyed it. Hope it answered questions. If you guys still have any other questions, you can comment in the comment sections. I will get back to every single question, or you can just send me an email if you like. You have my email in the description below, and you can just reach out to me. I'll answer again to any emails that are sent to me, any relevant emails, if it's about math and things like that. So that's about it for today's video. Like for part 2, I'm going to be adding more things about the you know, sine, cos, the other formulas. I'm going to be introducing tan and cotan and other trigonometry measures and concepts in it as well. I'm going to talk about the right angle triangle in the other videos. So like, comment, share this video to your friends, and stay tuned because I'll be putting out a second video that covers more soon. Alrighty. Thanks for your time.